which is kind of related to problem 8. It says a mass of a substance 75.8 grams. So we have 75.8 grams of that substance. Initial temperature 23.8. So instead of like the last problem, the substance was hot, now it's cold. It's 23.8 Celsius. It is mixed with water of mass 64.9 grams and initial temperature 74.5. So in this case, you have the water, which is initially kind of hot, 74.5 Celsius. Then you have the substance is cold, 23.8. Okay? So now we mix them together, and of course, when they come together, what is their final temperature going to be? Now, in this problem, they tell us, assume the substance is gold. They give us the specific heat of gold, and they want to know what is the final temperature. In the previous problem, which was kind of different, we didn't know the specific heat of the substance, but we were given the final temperature, right? So how are we going to do this? Well, we're going to say heat gained by substance, heat gained by gold, I can say, is equal to heat lost by water. So we have mass of the gold, specific heat of gold, and then change in temperature of gold, mass of water, specific heat of water, change in temperature of water, right? So we could say gold here, and then this is water. So the mass of the gold is going to be 75.8. This time we are given the specific heat of gold, 0.03. Change in temperature, how can I write that so that it's positive? Well, we know that when you mix the gold there, the final temperature is going to be greater than 23.8, right? So we're going to say the final temperature minus 23.8, TF minus 23.8. The mass of the water is going to be what? 64.9. The specific heat of water is 1. What's the change in temperature of the water? Well, we know the initial temperature of the water is 74.5. The final temperature is some number that's less than 74.5. It's going to cool down a bit, right? So in order to make that positive, I'm going to say 74.5 minus TF, okay? Or you could be doing it this way. You could say the heat gained by gold plus heat gained by lost by water is 0. In that case, you would say plus equals 0, plus equals 0. But in that case, what you would do, you would say the final temperature minus the initial temperature. And of course, this would be negative, and then positive plus negative would give you 0, right? So either you're going to have to put this to the other side and make it positive, or put it on this side, and then you can write TF minus 0. So right now, let's just go back to the older way. Set these two equal to each other. Okay? So go like this, go like this. If I had done it the other way, I would have switched these two. Okay? So now how do we solve this? Well, we got to take this, multiply it into here. So 75.8 times 0.03. So this is going to be 2.274 TF minus, then distribute this into there, 54.1212, then multiply this by there, 64.9 times 74.5, 4835.05 minus 64.9 TF. Okay? Then what happens? Well, this one here comes over here, makes it a positive. This one goes over there. So 64.9 plus 2.274, 67.174 TF is equal to, then add this to that side, 4835.05 plus 54.1212, then you have 4889.8 0.1712. Then divide that by 67.174. Then you have TF. TF is equal to 72.78 Celsius. Okay, and that is the answer, 72.78 Celsius. This actually had a little bit more math involved than the previous problem, because in the previous problem we already had the final temperature on both sides. We were only solving for the specific heat of the material. Here we already have the specific heat. We're solving for the final temperature, so there's a little bit more math involved. Then you can see it's 72. Now notice the water does not cool a lot. Okay? The gold cools down, heats up a lot more. Why? Because the gold is a metal, right? And metals tend to have very, very low specific heats. Low specific heat means it doesn't take a lot of heat to warm up a certain amount of the metal by a certain amount of temperature, right? It's only 0.03 calories per gram, whereas water takes 1 calorie per gram to heat up or to cool down. So who experiences the greater change of temperature here? Definitely the gold. Goes from 23 all the way to 72, whereas the water only goes from 74 down to 72. Okay, so this is another good example of a calorimetry problem. Thank you.